Hello and welcome. Today's topic is types of operating system. First one is the batch processing system. The operating system is early computers was fairly simple. Its major task was to transfer the control automatically from one job to the another. The operating system was always resident in memory. To speed up the processing, operators batched together job with a similar requirement or the similar type, like the job which is dependent on the s- hello and welcome. Today's topic is types of operating system. The batch of the batch processing system. The OS is in early computers was fairly simple. Its major task was to transfer control automatically from one job to the next. The OS was always resident in memory. The speed of processing, operators batched together jobs with similar requirement needs and run them through the computer as a group. Thus the programmers would leave their programs with the operator. The operator would sort the programs into batches with similar requirement, and as the computer become available, would run each batch. The operator will run the each batch. The output from the each job would be sent back to the appropriate programmer. The memory layout of batch system. First one, the operating system is residing inside the memory, and the next the remaining area is for the user program area. Here is the block diagram of the batch processing of operating system. The jobs are grouped together in a batch. For example, photons jobs in a one batch and the cobalt jobs are in a one batch. Those are grouped together and kept into memory for the execution. The advantages of the batch operating system. The batch processing system is particularly useful for operation that require the computer or peripheral devices for an extended period of time with very little user interaction. Increased performance as it was possible for job to start as soon as previous job is finished without any manual intervention. Priorities can be set for different batches. Disadvantage of the batch operating system is to interaction is not possible with the user while the program is being executed. In this execution, the environment, the CPU is often ideal because the speed of the mechanical input-output devices are intrinsically slower than are those of electronic devices. Next one is the multi-programming system. The most important aspect of job scheduling is the ability to multi-program. The multi-programming increases the CPU utilization by organizing job so that CPU always has one to execute. The idea is as follows. The operating system keeps several jobs in memory simultaneously. This set of jobs is subset of the job kept in the job pool, since the number of jobs that can be in the job pool. The operating system picks and begin to execute one of the job in the memory. Eventually, the job may have to wait for some task such as the input-output operation to complete. In multi-programming system, the OS simply switches to the execute another job when that job needs to wait. The CPU is switched to another job and so on. Eventually, the first job finishes waiting and gets the CPU back. As long as at least one job needs to execute, the CPU is never ideal. Next one is multi-programming. The multi-programming is the first instance where the operating system must make decision for the user. Making this decision is job scheduling. All the jobs that enters the system are kept in the job pool. This pool consists of all processes residing on disk awaiting allocation of main memory. If several jobs are ready to run at the same time, the system must choose among them. Making this decision is job scheduling. Finally, multiple jobs running concurrently requires that their ability to affect one another be limited in all phases of the operating system. including process scheduling and the disk storage and the memory management. Here is the memory layout for multiprogramming system. First, the operating system is residing inside the memory. After that, the number of jobs are allocated. The memory layout for the multiprogramming system. There is the main memory in which the operating system is residing, and there is a number of programs waiting for the CPU execution. And when the program finishes, the CPU will attach those programs to the secondary storage devices. Three different states of job in multiprogramming. There is a ready queue, running queue, and the blocked queue. Next one is the multitasking system. Technically, multitasking is same as multiprogramming. In a multitasking operating system, a single user can execute multiple programs at the same time. Multitasking is the system capability to work one or more than one job or process at the same time. It means that whenever a job needs to perform the input-output operation, the CPU can be used for executing some other job or process that is also residing in the system and is ready to use the CPU. The term multiprogramming is used for the multi-user system, that system that are simultaneously used by many users such as mainframe and the server class system. The term multitasking is used for single user system, that system that are used by only one user at the same time, such as the personal computer or the notebook. Next one is the multitasking system. The multitasking is the method of processing the multiple tasks concurrently in a single user system. For example, a user is running the separate program in four different windows. At the same time, the program in window 1 could be printing a document. The program in window 2 could be displaying the email for the user. A spreadsheet program in window 3 could be preparing sales reports, and compilation of a program is in progress in window 4. In this manner, a user may work on many tasks at the same time. Thus, progress of different tasks can be viewed on different windows in a multitasking system. There are two types of multitasking: cooperative multitasking and preventive multitasking. Types of multitasking system. Cooperative multitasking is a program can acquire the CPU for the required amount of time. A program can share the CPU with any other program that is executing simultaneously. Preemptive multitasking is the multitasking. The operating system allocates the particular time to a program. The CPU is preempted if a higher priority job arrives in a system. Here is the comparison between the multiprogramming and multitasking. The multiprogramming, it is used for multi-user system, that the system that are used by many users at the same time. And the multitasking, it is used for a single user system, that the system that are used only by one user at the same time. It, it refers to concurrent execution of multiple jobs that may be of same user or the different users. It refers to a concurrent execution of multiple jobs of same user. Next one is the multiprocessing, parallel and tightly coupled system. The most system to date are single processor system, that is, they have only one main CPU, where multiprocessor system allows, also known as a parallel system or the tightly coupled systems, are growing in importance. Such as system have more than one processor in close communication, sharing the computer bus, the clock, and sometimes memory also. Multiprocessor system have three main advantages: increased throughput. By increasing the number of processors, we hope more work done in less time. The speed of n processors is not n, rather than it is less than n. When the microprocessor cooperate on a task, a certain amount of overhead is incurred in keeping all the parts working correctly. This overhead plus contention of shared or resources lowers the expected gain from additional processors. Economy of scale. Multiprocessor system can save more money than multiple single processor system because they can share the peripheral, mass storage, and the power supply. If several programs operate on the same set of data, it is cheaper to store the those data on a disk